This is WTW team presenting our final app-DOM database project. So our team members are Haiqing Wang, Kejin Tang, and Yun Wu. My name is Yun. We finished all 6 milestones and listed the main accomplishments in the slides. So I will first go through the milestone 1, 2, 3, and Kejin will demo the milestone 4. And lastly, Haiqing will introduce the milestone 5 and conclude the presentation. So milestone 1 is about the project definition. The value proposition of our project is the app-DOM is an app review application that provides the app properties, reviews, and recommendations for app purchasers who are unhappy with unreliable app review platform. And what we originally planned to deliver is an app application with a large amount of data loaded at the base, and to provide the app purchasers information of app properties, reviews, and recommendations for their consideration, and also support the app CRUD operation. So in milestone 2, so we created these 10 tables and loaded data source at the base of our application. So you can see we have the app table that had the app ID as the primary key, and the name of the app, the category, the install numbers, price, and the size and other properties of each app. And also we have the user tables, and we also have 3 children tables at the users, like program hobby user, student user, and the developer user. And we link the users and the apps by the purchase history, dislike, recommendation, and the reviews table. So you can see in the workbench, we have we create a schema and all these 10 tables load the data. So here I can demo this part. So we successfully create the 10 tables and load the data source. Okay. So next in milestone 3. So we brought up 10 insightful questions that can answer with our data. For example, like here we focus on the app part. So for example, we have like which app had the most review counts, or what is the average review rating for the top 100 ranked apps. So we wrote the select statements to answer all these questions. So we have built the select from, order by, limit, group by, union all, left order union. We also use the sum if for some percentage calculation. And we also use the max, min, and average to get some properties like max average price, max, min, and average price of like app. These properties. So next part will be introduced by Kejin.
This is Kejin in WTW team. I'll give a brief conclusion about our milestone 4, which is about building the data access layer and the web application. We use Java Database Connectivity called JDBC, which is a Java API for interacting with a relational database to build the data access layer. Now let's look at our application. And these are all packages, these 4. And for DAL package, it's a layer that allows us to access the SQL server. And under this package, for example, like apps DAO.java class, we create some statements like create method, get app by app name, get app by app ID, update price, delete. These are the statements that we may execute later. And for module package, it's a representation of our module in our application module. And for example, like the apps.java class, we have some attributes about the apps class, And here's are the constructors, and we also have some getters and setters. And for tools package, it's an entry point into the application for the JDBC layer. And also, we'll use connection manager, the Java class, and to connect our database instance. And let's do a demo of our data access layer. And in Workbench, I'll recreate app zone first. And in order to check the CRUD operations clearly later, I won't load our original data in this demo. And here are the parts about the loading. And in inserter.java, we are actually going to exercise the data access layer, instantiate the data access objects, and insert data. Look at this console. We've successfully inserted, read, update, and delete the data. And we also can see our workbench. After running that class, we have some updates, like here. Now I'll demonstrate and do a demo about our web application view and controller components JSP implementation, which is about read, create, update, and delete. For controller, it's just servlets. And for view, it's JSP templates. JSP, it's a Java server pages. It's a web framework to help create dynamic HTML web pages, using servlets to respond to requests and templates to render the web pages. And after inserting the data, we can just run the server. And here, this is the entry point in this application. We have a find app controller. We can search by app name. And after submitting, we can see it does a do post request, and that sends a post request to the server. And we can get this app information here. And let's look at the code of find app controller. We can have this operation simply because we, execute the doPost method by using getAppByAppName method in appsDAO class, and at the end, this controller will render the findapp.jsp page, which goes hand in hand with findapps.java. And let's look at the create app controller. Actually, we have this, we'll do create app first. We can create an app by filling these blanks. For example, if we want to create an app with the name AppZone, first check this app does not exist in our database now. See, it's not here. And after submitting, it says successfully created the app with the name AppZone. And checking Workbench, and see we successfully created an app with the name AppZone. We can have this operation simply because in the create controller, it will execute the doPost method by using create method in appsDAO class, And at the end, it also will render app create.jsp template. We also have a delete controller. We can simply delete the app with the name app name 2 by clicking this delete button, and this number is the app ID corresponding to the app that we want to delete. First, see the app ID 2 that exists in the database now. See, it's here. But after submit, it says successfully delete the app with ID 2. And let's check. Now the app ID 2 does not exist anymore, the whole app. And also we can have this operation simply because in our app delete controller, it will execute the do post method by using delete method in apps DAO. At the end, it will render app delete.jsp template. When finding apps, we also can update apps by clicking update button, and we see that we can update an app with updating its price attribute. For this app, now the price is 0.99. Now the app ID 3, the price is 0.99 now. And when we update it to 0.2, and after submitting, it successfully update price for app name 3 from 0.99 to 1.2 and checking workbench. We see that the app ID 3, the price now is 1.2, which means we've successfully updated the price. And we can have this operation simply because in app update controller, it executes the do post method by using update price method in apps DAO, and also at the end it renders app update.jsp template. And we also, when we find apps with the information here, we also can see its views, and by clicking this button. And see, here's the detailed information for the reviews for app ID 3. And we can have this operation simply because in the app reviews controller, it executes the do get method by using get reviews by app ID method in reviews DAO. And also, we also can delete this review. First, check the review ID 5 does exist in our database. Here. But after we submit, it says successfully delete the review with ID 5, and let's check we've deleted successfully. See the review ID 5, the ID with 5 is not here anymore, and which means we've deleted successfully. And we also can check the recommendations for an app after clicking. Oh yeah, we can delete the review operation just because in our review delete controller, it will execute the do post method. By using the delete method in reviews DAO. And at the end, this controller also will render review delete.jsp page, which goes hand in hand with review delete.java. Yeah, also for finding an app, we also can see its recommendations by clicking this button. Oh, this is not here anymore. Let's find another app here. For example, like the app name for app, when we check its recommendations, here's the detailed information. We can have this operation simply because in our app recommendation controller, it runs do get method by using get recommendations by app ID method in recommendation DAO class. And also we can delete this recommendation. Let's check recommendation ID 5 does exist first here. And after click the button, it shows we've successfully deleted. And let's check in Workbench. Now the app ID 5 does not exist anymore, which means we've successfully do that. And we can have this operation simply because in our recommendation delete controller, it will execute the do post method by using delete method in recommendation DAO class. And also at the end, this controller will render recommendation delete.jsp templates, which goes hand in hand with recommendation delete.java. And that's the end for our conclusion of milestone 4.
Hi, this is Haiqing. Now I'm going to walk you through our milestone 5, data warehousing. In this milestone, we made the hypothesis that weather has an effect on purchase of apps in the travel and local category. We imported several external datasets: the global temperature dataset, which is the records of global land average temperature with date; the US temperature dataset, which is the records of US land average temperature with date; the China temperature dataset, which is the records of China land average temperature with date. And also we want to track the correlation between raining and app purchase. So we use the US precipitation dataset, which is the records of US 48 states precipitation data in 2018. Our datasets are mainly from KAGO or NOAA, which is the National Centers for Environmental Information. After we obtained these datasets, we used Clover application to extract, transform, and loaded external datasets. We joined with travel app purchase amount and purchase date data from our existing datasets and wrote the joined data to an Excel file. From the Excel file, we generated these graphs. First, let's look at the correlation between temperature and app purchase amount. We do see some correlation between the app purchase and temperature in late 2015 or early 2016, or late 2016 and early 2017, considering either global temperature or US temperature or China temperature. For the precipitation, we don't see any correlation between precipitation or with app purchase. And when we look at the app purchase, the correlation between app purchase and seasons, we do see an increase in the app purchase in summer or winter. Overall, we do see some correlation between the temperature and app purchase in the travel category. But to make our hypothesis more valid, we need more data points to support our conclusion. In milestone 6, we walked through what we have done in this whole semester, and we reached these conclusions here. First, we have actually already fulfilled our value proposition as stated in milestone 1. And when we look at what we actually delivered and what we plan to deliver, first, we created an app review application with 10 classes defined and more than 100K rows data loaded. Second, we built DAL for the data model and a complete data-driven application. Third, we extracted, transformed, and loaded external dataset to study our hypothesis in the milestone 5. That means we have actually already met what we initially planned to deliver. For our future work, we have several ideas here. First, keep our application updated with more recent data. Since most of our data are before 2017 or 2018, it is very worthwhile to keep the data updated so that more data sets we have more data points to support our hypothesis or any ideas to study in the future. Second, provide more user interfaces for users to interact or even contribute to our database. Third, polish our front-end UI to make it more user-friendly and beautiful. Fourth, we can build a platform with extensive APIs on mobile devices, adding more features like advertising or providing recommendations and payment. These are our works for this whole semester. I hope you enjoyed it. Thank you.